because the importance of that is too much, because especially if you plan to do anything in future about, for example, your career and how to choose a degree in Canada and this kind of stuff. And it's a very good session. Then I strongly advise you to make sure that you attend that session. I'm going to make an announcement further about that, but I'm going to talk to your teachers on that day that you do not attend the first period, at least the last half an hour of your period. And it should be fine. Then please make sure that you just check your notes, my announcements online about the hour of that session. But for sure, it's going to be exactly the same day next week, which is going to be 21st of April, next Tuesday. Okay. Any questions so far before we continue?
No.
No?
No.
Okay. Before that, let me grab what did we do last session. Give me a second. I have to also do my laptop upside down. Okay. Okay, that I can see that, guys, on the very last session that we covered some stuff. We talked about, I should say, the basic trigonometric functions. We did essentially lots of stuff, as I can see. We talked about use the symmetry and use the special triangles to find the angles of trigonometric functions, and we ended up with sine, cosine, tangent, and cotangent of an angle. Remember that, huh? Okay, now, before we continue today, I'll just give you one example. Today is going to be April 14. April 14 is going to be function 11. I'm going to give you the kind of a starter. You please think of it for 2 minutes. Then I solve that for you in order to review the things which we had, I should say, last week. Okay, I'm just going to give you guys an angle. I called it angle alpha. I think that the alpha is pi over 4, which we talked about that. We looked at as a pi over 4 as one of the special reference, I should say, angles in trigonometry. And the thing which I'm going to do that right now is that we use this one, but I'm going to just give a ratio to that 5 pi over 4. And the alpha as an angle is this in terms of the radians. The thing which I want to ask you, please, localize that in a unit circle and find the 4 trigonometric ratio, which is the sine, cosine, tangent, and cotangent of this angle, based on the things which we talked about that on last Thursday. Please do this, and then then in 2 minutes I think should be fine. Then I just join you to just solve that for you. Then it's a kind of a review of what we did last week. Any questions? You can see that 5 pi over 4. I'm here if in case if you have any questions. Guys, are you working on it? Guys, are you done? Hello? Anybody there?
Not yet.
Who was? Gloria, is it you?
Yes.
Good. How about you, Philip, Rose, Faris?
Not yet.
Not yet? Okay. Okay, just 1 minute. I just, Julie, who's done now, guys? Nobody yet? Let me join you guys. Let's do that together. Who is done? No one yet? Clarice, Philip, Gloria, Rose.
No.
Not yet? Okay. No one is done? Okay. Let's see that together. Okay. Guys, look at this. For this one, we have the angle is how much? Pi over 4 divided by 4. If we are here from 0, going to the pi over 2, which is going to be here, then here is going to be pi. Then here is going to be 3 pi over 2. Then again, go back to the 2 pi. The 5 pi over 4, how much in terms of the degrees is that? You put 180 instead of the pi and multiply to the 5. How much is that? Guys, why nobody is speaking today?
I'm thinking.
Okay. 5 times 180.
5 times 118 is
900? Then 900
yes,
divided
900.
by 4.
900 divided by 4.
That's right.
896.
Becomes 2. 200?
Oh, divided by 4. Okay.
That's right.
Oh, my head is not so good today. I think
225.
slow.
Which essentially it shows you that 5 pi divided by 4 is equivalent to, say, to what? To 225 degrees. Then in which quadrants my angle is located? 1, 2, 3, or 4?
Can you repeat this question? I don't hear clear about the question.
Yeah, sure. I ask you that if the angle which I'm trying to analyze it trigonometrically is 5 pi divided by 4, which is equivalent but to 225 degrees, in what quadrant of this unit circle with the Cartesian frame is located? It should be at this quadrant, quadrant number 3, which is between 180 and 270 degrees then. That's right?
Yes.
let me show this angle. It means that if I have this one, which represents, I should say, this one is the fixed arm of my angle, and this one is the moving arm. And if I start from, let's say, for example, from A, I have the O, then I go to the B. This angle which is created here is how much? 5 pi divided by 4, correct? Guys, is it clear for you what happened?
Yes.
Awesome. And now I try to find, I should say, the sine, cosine, tangent, and cotangent of this angle, which is located at quadrant number 4. But guys, the problem is that as what we learned a couple of days ago, we noticed that from the lectures which we had and from the notes which you find, we can always transfer these angles back to a reference angle at the first quadrant. Let me show that to you. That's what we talked about that. Do you remember that, guys, that this map which we created on Thursday, we had angles pi over 6, pi over 4, and pi over 3, which we were able to find the coordinates of them by the special triangles. Do you remember that?
Yes.
Yes? Then as a result, when I have an angle like that, which is going to be 225, how can I move it back to the other angle? To the first quadrant. Can I find any angles inside my first quadrant, which is one of the reference angles? What are my reference angles, what they were? Can you remember them, reference angles? 30 degrees, 45 degrees, and 60 degrees. Do you remember that? Which is this one. 30, 45, and 60 degrees. And with these angles, we know everything about them. We know their angle, we know their, I should say, the Cartesian coordinates. Right? And now, in order to do that, what I'm going to do for this purpose is that in case if I just want to find this angle to what one represents, can I say, first of all, I write it by the degrees that we learned that this angle 5, let me write it here. I know that the 5 pi divided by 4 equals to 225 degrees, correct? That's what I know. Can I write 225 equals to 180 degrees plus 45 degrees? Are they equal?
Yes.
I say 180 plus 45, oh, it becomes 225. That's right. Or I can say equivalently, I can write what? It was in degrees, I can write the equivalent one in the radians. I say what? I say that 5 pi divided by 4 should equal to what? Pi plus pi over 4 in terms of the radians. These two demonstrations exactly are the same, correct? Any questions, guys?
No.
No.
No? Okay. If that's the case, it means that my reference angle is going to be so true. It's going to be 45 degrees. Why? Because you remember that from, let me show you that slides which we had. I think it was in this map that we said that on the last week, that if the angle is at the third quadrant, you see point C, if the angle is at the third quadrant, the angle who comes at the first quadrant, you just continue it back. You see, the angle is at point C, and imagine this is point O. You continue CO, go all the way to the other side to get another symmetrical point. Do you remember that from the symmetry? It means that then as a result, I can do what? I continue from point BO, go back all the way to the point here. I call that point what? Point A. You see what happens? If you remember last week, we said that point A has 4 brothers. For example, imagine that point A is Faris. Faris, are you still there?
Yes, I'm here.
Yeah. If point A is Faris, as you learned last week and what we talked about, we said that Faris has at least 3 other brothers that they exactly behave as Faris behaves. When Faris is, for example, laughing, they are laughing. When he's crying, they are crying. When he is running, they are running at the same time. It means that they behave exactly at the same time like each other. And you saw that last week, how we can find them. We used to find these ones, for example. We had, for example, my marker. I go all the way to there. Maybe that's not the right color. Maybe you do not see this one. Let me change the color. You saw that the first one is parallel to the x-axis until it reaches to the boundary and the circumference of that circle. This is going to be another point A. It's going to be another Faris. And if I also move down from here, I'm going to find another brother of the Faris, which is point B. And I just do the same thing for point B here. I come to this point again, another point, which is another Faris brother. Then Faris, and now I'm going to introduce you to your brothers here, here, and there. I call this point C, for example. Then if A is Faris, these points also behave exactly as Faris. It's like the mirror image of the Faris. That's what we talked last week. And also we noticed that if B is represented as a symmetry with point A, if this point is 5 pi divided by 4, this angle becomes how much, guys?
45.
45 or pi over 4. Give me 1 second, I come back in a second. Okay, and now we have this one here. And then as a result, I find another point 5 over 4. We said that, if you remember from last week, we said that if point A, which has a coordinates of x and y, what is the coordinates of the point B?
Minus
Hello?
x minus 1.
That's
Y.
right. Minus x minus y. That's all. I haven't done anything new. I'm doing the things which I learned before. I said that point A and point B, because of the symmetry which they have, is the same, like 2 brothers. If x and y is the coordinates of the point A, then minus x minus y is the coordinate at point B. They are minus because they are at the third quadrant. Third quadrant, x is minus, y is minus. Right? That's what we talked about that before. And now, the thing is that, okay, and now I have the angle. I have pi over 4. And also the thing which you learned before was that for pi over 4, you can just come 5 pi divided by 4, which is essentially pi plus pi over 4, you get to the other point. That was the way which we talked about that last week. We said that we can connect these points together either by knowing the Cartesian reference frame or by knowing how much degrees they are as an angle. Now, by pi over 4, guys, last week we talked about special triangles. I'm going to show the thing which I have done on the last week, on the last day of the class. If you remember last week, what did we say? We said that if the angle is pi over 4, then I have, at this point, which is x and y, I define x and y coordinates by projecting it at the x, y, and y. Then I have x and y. What did I say? I said that I introduced to you a kind of a triangle, which this is called special triangles. And we said, when we talked about that, we said that for these special triangles, I define it such a way like that, that I say the pi over 4, these are my angles. This is going to be 1, this is going to be 1, the length. Then using the Pythagorean theorem, you get what? Square root of 2 on the hypothesis of, I should say, on that triangle. Then we said that if we want to reconstruct the same triangle, I cannot just remove it from this page, place it there, and make the triangle. I cannot do that because the length is square root of 2. The length of hypothesis on the unit circle, because that's the radius, it's 1. Then in order to do that, I had to scale it, divide every length of this triangle by square root of 2. Then I got square root of 2 becomes 1. 1 divided by square root of 2 becomes the square root of 2 divided by 2. And also the same thing for the other angle. Then if I take this triangle from there, remove it from the page, paste it there, I get the same length there, which is the square root of 2 divided by 2, and the square root of 2 divided by 2. Then as a result, what do I get? It was that I get x with this number, y by this number. Correct? You remember it from last week, guys?
Yes.
Yes? Okay. Then if you remember it from last week, then the x and y which I have here for this angle, this is the things which I know. It becomes what? Becomes square root of 2 divided by 2, correct? And square root of 2 divided by 2, right? That's the basic, the things that we learned before. Now, I'm going to find four trigonometric functions for this angle. What is the first one? The first one, which I'm going to just find for this one, is going to be the sine function. Can you see this, guys, if I write here?
Yes.
Awesome. I'm going to, let me make it in a neat way. It's going to be my sine. It's going to be my cosine and tangent and cotangent. Okay. Okay. The first one, let me, I wish if I hadn't just written 5 here. Okay. Let me start with the first one. In case, if I want to define the sine, the sine, what is the definition of the sine, guys? Based on the things which you learned. The definition of the sine is going to be this. For the sine of the alpha, what was the definition of it? It was the x that you have as a coordinates divided by what? Divided by the hypothesis of that thing, which is x divided by r, correct? If that's the definition of the sine of any angle, for the angle which I have 45, how much is that going to be then?
Square root of 2 over 2.
That's right, becomes the square root of 2 over 2. This is for alpha equal to what?
45.
Huh? It's 45. Well, look at that. For the 45, the sine of that angle is square root of 2 divided by 2. But we are looking for this angle, 5 pi divided by 4, which is going to be these coordinates minus x minus y. Then when I'm looking for the x as a definition divided by the r, my x here is something minus, correct? Correct, guys? Then I have to add one minus sign there. How about let's do something different? How about the cosine of 5 pi divided by 4? As a definition, you know what is that? What is the definition of the cosine? The
Y
definition.
divided
Oh,
by
sorry.
r.
I'm so sorry. I made a mistake. The sine is going to be y. I'm so sorry. For the sine, the definition is y divided by r, which it doesn't make a difference because x and y are the same. For the cosine, sorry, Rose, to interrupt you, it becomes, what is the definition of the cosine?
X divided by r.
X divided by r. For the angle 5 pi divided by 4, what is my x? X coordinate is this one, minus x, and x comes from the square root of 2 divided by 2. Right? Square root of 2 divided by 2, and x divided by r. What is my r?
1.
1 divided by 1 becomes 0. It becomes 1 itself because the number itself. And I know that my x has to be minus, then I just put 1 minus sign there. Correct? Any question, guys? Are you okay, or you got a little confused? Please don't be shy, ask. Hello?
Hello.
Is it you, Faris?
Yes, it's me.
Yeah. Do you have any questions? Is it okay so far?
No.
It's not okay?
Yes.
Uh-huh. How about you, Philip, Gloria, Rose?
Yes.
How about Rose and Philip?
I don't have question.
Uh-huh. Guys, then you see that so far, the strategy which I followed was that because my angle 5 pi divided by 4 was confined in the third quadrant of my plane. First of all, the first thing which I did, the first step, was that use this relationship which we know to find the brother of the b on the other side, which it behaves exactly like this one. But I know the relation between this point and that point. I know that if this point is x and y, this point has to be minus x and y, because this one is at the first quadrant, this one is at the third quadrant. And I know because of the symmetry, it means that x and y are equal, but their sign is different. But what is the x and y of the pi over 4? I know that based on the things which I used it as special triangle. I have to memorize it, that for the angle pi over 4, x is the square root of 2 divided by 2. Y is the square root of 2 divided by 2. Correct? Then if I know that, for sure I can say, okay, B should be the same thing. Because that was the reason that we talked about the symmetry. Because if I know how A behaves, I know exactly how B behaves. That's right. Now, I'm going to go to the another trigonometric function, which is going to be the tangent. Do you see this color when I'm writing with this color, or this is too blank? Is it okay?
Yes.
Tangent of pi, 5 pi divided by 4. What was the definition of the tangent?
Y divided by X.
That's right. Y divided by X. Okay, in that case, what is my Y? My Y is the square root of 2 divided by 2 for point A. But for point B, it's going to be minus Y. That's right. Then it becomes minus square root of 2 divided by 2 divided by what? My X. What is my X?
Square root of 2 over 2.
That's right. Square root of 2 over 2. And it should be minus because Y is minus there. Then how much is that, the tangent?
1.
Plus 1. That's so true. Then for this tangent, we got this one. Guys, but also, I just want to highlight something here. Look at this ratio that we have Y divided by the X. Look at this. Y divided by the X. Is it like that I divided sine by the cosine? If you divide sine by cosine, the r are the same, then you are left with the y divided by the x. Can you see that?
Yes.
We're going to talk about that more in future, but at this stage that we are working numerically and we can see these numbers, I can write it like that. And I say that, okay, the tangent of any angle, it's going to be equal to the sine of that angle divided by cosine of that angle. We're going to talk about this identity more. You see that, guys? Yes? We're going to talk more about this identity more, but at this stage, you learn that for getting the tangent of any angle, we can divide y by x over x, or I know that the tangent of the alpha, it can be written as the sine of the angle divided by the cosine of the angle. Okay, we are going to talk more about that in future. Okay. And now, I'm going to go for the cotangent of the 5 pi over 4. Based on the things that we learned, guys, what is a cotangent? Definition.
X divided by Y.
That's right, x divided by y. And I see my x and y is there, and it's going to be exactly the same thing. Becomes minus the square root of 2 divided by 2 over minus the square root of 2 divided by 2. Becomes how much?
Plus 1.
Plus 1. That's so true. Then look at this one, guys. We can see two things from here, which we are going to develop one more identity. Look at the definition of the cosine. The definition of the cosine is x divided by y. Can I write the definition of the cosine like this? Sorry, cotangent, not cosine, cotangent of alpha. How much is the cotangent of the alpha then? Can I say that for the cotangent, if I can do the cosine divided by sine, I get the x over y, because cosine is x over r and the sine is y over r, then if I divide cosine, I get x over y, because r is the same, they are just gonna vanish. Is it right? We are going to talk about this stuff more, but at this stage that we are here, it's good that to show this one stuff also. Right? Any questions?
No.
No? If you are confused about these two identities, we are going to work with them more in future, but it's good to see them right now. But another identity, I'm just going to show that to you, is that, guys, look at this side of the cotangent and the tangent. This is sine over alpha, sine alpha over cosine of the alpha, but for cotangent is cosine alpha divided by sine alpha. What is the relationship between them? Can you see that? Any guess? Let me write it here. Okay. Let me show that to you in a different way, which is going to be some identities. These are going to be our first identities. Guys, we learned so far that the definition of the tangent of angle, I call that angle x, becomes what? In terms of the sine and cosine. Becomes, this definition is going to be the sine of the same angle divided by the cosine of the same angle. Correct? That's what we saw before. And the cotangent becomes what? Cotangent of the x becomes what? Becomes, the ratio becomes the cosine of x divided by the sine of the x. So far, so good? If I look at the right side of these definitions, can I say that for the cotangents, what is at the denominator of the tangent is now going at the top? And what is at the top becomes at the down. You see that? Sine x divided by cosine x, but for this one is cosine divided by sine x. You see that, guys?
Yes.
Then can I say that as a very important identity that the tangent of the x is equal to the inverse of cotangent of the x? Or I can say the cotangent of the x is the inverse of the tangent of the x. Can I say that? Then, if I have a tangent. If I multiply both sides together, from this one, we are going to get to a very important identity, that the tangent of an angle x multiplied to the cotangent of the x becomes how much, guys? What do you think? These two are inverse. For example, 5 and 1 over 5. When you multiply them, what do you get?
1.
1. That's right. Then I get 1. This is a very, very important identity. We are just going to see it now, but we are going to go back to these ones a little bit later. At this stage, we are seeing them. And you see, we have now, I should say, 4 identities, that the tangent of the x is the ratio of the sine over cosine. The cotangent of the x is the ratio of the cosine divided by the sine. And then we saw that then as a result, they are the inverse of each other, which it means that if they are multiplied together, it gives you 1, right? Correct? Any questions, guys, on this page?
No.
No? Okay, let's do one more example, then you can apply all of them together. Okay, I'm gonna write an example, and I said that the example is gonna be this. Example, I'm gonna give you the angle. The angle is gonna be, I call the angle beta, which is a Greek word. It's gonna be this angle. It's gonna be 11 pi divided by 6. Guys, for this angle, 11 pi divided by 6, use the exact thing that which we did, the exact copy of the things which we did, and try to find which cycle is that, which quadrant is located, and find sine, cosine, tangent, and cotangent of the angle, and show these identities that we talked about that. Okay, does it make sense?
Yes.
Yeah, give it a try. I give you 5 minutes, then I just come to just solve that with you together. Any questions?
No.
No, that's fine. Guys, are you done?
Yes.
How about the others?
Yes.
Oh, great. Philip, Ferris, how about you?
Yes.
How about Philip?
Yes.
Ah, okay. Let's do this. I'm gonna draw. This is gonna be my Cartesian coordinates. Okay, now, in order to, first of all, the first thing which I have to just make sure this is done is what? Is to find at which coordinates, which quadrant this angle is located. 11 pi times 6. 1, 2, 3, 4. Which quadrant is that?
Fourth.
4. Because 11 pi divided by 6 becomes how much degrees?
330.
That's so true. Then it means that if I'm looking for that angle, the angle is going to be this. It's going to be from here. It's going to be the starting arm, then goes all the way from the quarter 1, 2, 3, comes all the way, come here, 330. Becomes, for example, it's going to be the angle A. It becomes B. Then the angle is essentially this. 330. Okay. And now when I'm at point B, where is my brother? Who knows? My brothers are going to be here. I'm going to show you how to find them. I just use my ruler. I just go one all the way up there. One of them is here. I use my ruler parallel to the x-axis. I reach to the circumference of the circle. One of them is here. If this is B, I call this B again. I call this B again. And again, my ruler parallel to the y-axis until it reaches the circumference of the circle. Then it's going to be another B because they are all the same. There is no difference between them because of the symmetry which is introduced by the circle. Okay, and now I have these ones there. Okay, and now the question is that for point B, first of all, I know that these are my brothers. The point is that for point B, I have these coordinates X and Y. I have to find them. But I'm looking for the brother which is located at the first quadrant because it becomes the reference angle, right? Then out of these brothers B and B here, I'm looking only at the one which is at the first quadrant, correct? Then what should I do? I come to write the angle. This one. Then I'm looking all the way to find this angle, which I'm highlighting it by coloring it. This is a good brother because it helps me to figure this out, what is X and Y. But the problem is that, how much is this angle?
30 degrees.
30. That's right. Why it is 30? Because if you remember from, let me show you. Yeah, let me show you the map which we had before. I think it was on last Tuesday that we said that if alpha is there with point A, another symmetrical point at the fourth quadrant becomes 2 pi minus alpha. That's right. Then the question is that, guys, you can ask yourself this question. Why it is 30? You solve this equation. You say 2 pi minus alpha is what? Is 11 pi divided by what? By 6. Am I right?
Yes.
That's right. Then I have to solve it for the alpha. Then you say, what happens? How much is the alpha? Alpha becomes what? You take alpha to the right, becomes positive. You take 11 pi divided by 6, bring it over there, becomes 2 pi minus 11 pi divided by 6. Then how much is alpha? Take the common denominator, becomes 6, becomes 12 pi, because I multiply 2 pi to the 6, becomes 12 pi minus 11 pi. Becomes what? Becomes pi over 6. Then if that's the alpha, it becomes, question mark, becomes pi over 6, which is 30 degrees then. Then you see, guys, in order to find the angle, this map, which we produced last week, it's essential. You find your angle at this quadrant, you know your brother at the first angle is 2 pi minus alpha away from you. Then this angle equal to 2 pi minus alpha. Did you got it? Yes? Everyone says yes if you got it, or say no if you do not get it.
Yes.
How about the boys?
Yes.
How about Ferris? Ferris? Ah, maybe he stepped away. Okay, then pi over 6. Then my reference angle is what? 30 degrees or pi over 6. Okay, I go back to my original map. For pi over 6, what is my coordinates from that map? Pi over 6 is this one. Becomes the square root of 3 divided by 2 and 1 over 2. Correct? Because that was the reason I tried to find a brother at the first quadrant, because if I'm at the first quadrant, by helping of the special, I should say, triangles, I was able to find these numbers. I can memorize them, correct? And now, if I'm there, how much is going to be, for example, oh, before that, if this is this one, x and y, I see that the x, if you see the x is going to be the same because of the symmetry, but the y is the same but with the minus sign. You see that? Okay. Then, what is the sine of this angle? I'm just going to put that as guys, what time is it?
12:20.
Uh-oh. We passed the break, huh? Guys, we finish this one, then we take the break. Is it okay?
Yes.
Okay. Great. Look at that. For the sine of (11 pi divided by 6), I have to find this ratio, which is going to be the ratio of the x divided by the y. What is my this point? B equals to what? B, my x is what? Square root of 3 divided by 2. What is my y?
-1/2.
That's so true. For this point, what is my x? Sorry, it's going to be r. Why is I did for r? It's going to be, because my x is what? Is square root of 3 divided by 2 divided by the r. R is what? 1. Then it's nothing. Then this is my sine of that angle. Is it good so far? How about the
Yes.
cosine of 11 pi divided by 6? I know the definition of the cosine is what? Is that for that angle, it's gonna, oh guys, I am extremely sorry. I keep mistaking them. Sine is y divided by the r. I'm so sorry, it's my mistake. It's gonna be y divided by r. For cosine, it's x divided by r. Then, guys, sine is gonna, the last one was incorrect because the sine, it's y divided by r. My y was minus 1 over 2. Becomes minus 1 over 2. But for the cosine, becomes what? X. What is my x?
Square root of 3 over 2.
That's right. Becomes the square root of 3 over 2. What is my tangent of 11 pi divided by 6? It's the ratio of what?
Y divided by x.
That's right. Which it means that my y is what?
Minus 1 over 2.
Minus 1 over 2 divided by x. What is my x?
Square root of 3 over 2.
That's right. Becomes how much?
Minus square of 3 over 3.
That's so true. And how about the cotangent of this angle?
It's minus square root of 3.
That's right, because this is the x over y becomes, what is my x? Square root of 3 divided by 2 divided by what?
Minus 1 over 2.
That's so true. Becomes how much at the end?
Minus square root of 3.
That's so true. Then guys, you see that for any angle which you are given, first by the symmetry, you can find which is the brother of that angle at the first quadrant. If this is either 30, 45, or 60, you know the reference angle. Then you can localize what is x and y for that point. Then using the basic definition of the sine, cosine, tangent, and cotangent, you can find the numerical values of them. Does it make sense to everyone?
Yes.
Any questions?
No.
No? Okay. If you have no questions, let's take a break. It's 12:25. Please come back by 12:40. Huh? Right. See you then by 12:40, guys. Then. Hello, guys. Are you back?
Yes.
Yes, nice. Okay, let me just put my laptop upside down. Okay, and now it's going to be page number 4. Now we are just going to do something different. Now we are just going to do the plotting of page number 3, number 4. Okay. Okay, now let's move on because we have to do something different now. Any questions, guys, before on the course before we just went for the break?
No.
No questions? Okay. Then, guys, as you noticed, while we were working on a trigonometric function, we were talking about that fact that if I have my Cartesian coordinates and if I have my circle, unit circle, if I have my unit circle there, which is going to be the x, this is going to be the y, and we saw that if I have an angle, which that angle is going to be represented by alpha, then what did we see before? Before we go for the break, what did we see? If I make a normal there, this one represents what? Guys, can you see this if I write here?
Yes.
It represents my x, and this one essentially represents my y. Then what did I learn? The thing which I learned was this, that I learned that the sine of an angle like alpha is represented by a simple ratio, which is going to be what? Which is going to be essentially the y, the length of the y, divided by the r, which the r, as you saw that, it's the radius of the unit circle, which essentially here in this case is nothing, just the y itself. Correct? That's what we covered that before. And now I'm going to use this formula to see what's going to happen. That is the definition of the sine. Okay. Then now, the thing which I'm going to do, I'm going to use this concept that we can find a trigonometric ratio, I should say, ratio of one curve, one arc, or one angle, and define a function like that. Say what? For example, I'm going to define a function, and I say my function is this. I say I define a function in a way that any argument which I introduce, x, is transformed into what? The sine of the x, which x belongs to what? Any real number. And that's how I define a trigonometric function, sine of x. That any arguments can be transformed to the sine of that argument, and that argument, which is x, it can be any real number, any positive, negative real number. That's how I define f of x. Then as a result, I can just come here and write this and say that y equals to f of x is the sine of the x. Correct? the x can be any real number, which it means that the domain of your function is what? Any real number, right? Right, guys?
Yes.
Okay. And now, we are going to do two things before we end today. Before we end and just go for the lunch, we are going to do two things. The first thing is that, first of all, we are just going to find out about, I should say, let me just put that on the other page because I need it on the other line. Let me put it there. I'm just going to write this like that. I said that, okay, I'm going to introduce I'm going to make an angle. Okay. If it's going to be my x, and here it's going to be my sine of the same argument. I'm just going to give some numbers to see what's going to be the value. Let me divide this in columns. It's going to be, my first angle is going to be 0. The other angle is going to be pi over 6. The other angle is going to be pi over 4. Pi over 3. Then I have pi over 2. I have 2 pi over 3. I have 5 pi over 6. And I have pi. Let me isolate them from where they are. Becomes pi over 6. It's this one. It's this one. It's this one. This one. This one. Okay. This one. Okay. Now you just please help me to fill out the chart. Okay. Okay. If my x is 0, let me also show you this graph which we had. If we have the angle is going to be 0, how much is my y? At point 0, I have 1x, y is going to be 0. Do you remember this map?
Yes.
What is the sign of the 0 then?
0.
0, that's right. Because there is no any other, I should say, y. Then the sign of 0 is 0. For pi over 6, what is the y coordinates? You see this map, pi over 6, it goes to point which the y is 1 over 2, right? How about pi over 4? 45 degrees, pi over 4. What is the y coordinates from the map which we got?
Square root of 2 over 2.
That's so true, square root of 2 over 2. How about pi over 3?
Square root of 3 over 2.
That's so true, square root of 3 over 2. How about pi over 2, 90 degrees? How much is the y?
1.
1. So correct. It becomes 1. Okay, these are the things which we knew. But how about this one, guys? 2 pi divided by 3. 2 pi divided by 3 becomes 36. 360 divided by 3 becomes 120 degrees. It's at the second quadrant. 100, I should say, you see that if it becomes this, we saw that if the angle is at the second quadrant, we said that the characteristic angle, the reference angle, is pi minus alpha, correct? We say that here for the 2 pi over 3, we said that pi minus alpha, alpha is the angle which is going to be the reference angle, equals to what? to 2 pi over 3, right? Then what do we get? How much is the alpha? Alpha becomes pi minus 2 pi divided by 3. Becomes what? 3 pi minus 2 pi divided by 3 becomes pi over 3. Correct? Does it make sense?
Yes.
That's right. Then it makes sense that if you have an angle which is 2 pi divided by 3, by using this map, which we produced it before, it means that if this is at the second quadrant, it's going to be by what? Pi minus alpha. Then you say pi minus alpha equals your angle. Then you search for the alpha. Then it becomes 30 degrees. It equals to 60 degrees. What is the y of pi over 3? It's square root of 3 over 2. That's right. Did you get it? What happens, guys? 2 pi over 3, his brother angle, the reference angle, is pi over 3. Right? For pi over 3, what is the y, which is equals exactly to the sine of 2 pi over 3? For pi over 3, it was this, square root of 3 over 2. I got the square root of 3 over 2. Right? Guys, is it okay so far for everyone?
Yes.
How about you, Philip, Ferris, and Gloria?
Yes.
How about Philip,
Yes.
Ferris? Okay. And now, okay, how about the 5 pi over 6? How much is the 5 pi over 6? How much is that in degrees?
150.
150. It means that this is still on, let's say, the second quadrant. If this is still the second quadrant, you can still find the same thing. You say that the second quadrant means that the angle is pi minus alpha. You see that if I write? Equals to what? 5 pi over 6. How much is the alpha then? Pi minus 5 pi over 6, which equals to what? Pi over 6. That's right. The
Yes.
pi over 6, the y is 1 over 2, then it gets the same thing. 1 over 2. Correct? And essentially, if you see, guys, then that was the reason that we said that point A, B, C, and D, because of the symmetry, they behave the same thing. Because if you know the y or trigonometric ratio of one angle, you get the rest of it because they're going to be equal. How about the pi? What is the y of the pi?
Zero.
0. That's so true. Then I put the 0 there. Okay, guys, any questions so far? I'm filling out this chart.
No.
Great. Okay. And now, let's see. How can we just... Now, the thing which we want to do is that we try to plot this function. This is going to be my y. This is going to be my x. And this is going to be 0. First of all, the thing which I do is that I'm just going to come to locate, I should say, these points on my x-axis. That's right. Then 0, pi over 6, pi over 4, everything is going to be on, I should say, on my y-axis. Let me locate them here. It's going to be 0. I'm going to be here 2 pi here. I'm going to half of it, I make it half of it pi. No, it's not half of it. Let's see how much. Okay, now this one is this. Okay, on the half, I just put this is pi. And this one is going to be 2 pi. You see that, guys? You see that 2 pi's. Then you see that the domain of the function which I decided to plot is between 0 to 2 pi, which is one full circle of the circle which we had. Which I mean that in order to plot it, you have the full angles around one circle. So 2 pi. My range is going to be between to what? Is between 0. You see my range is between 0 goes to 1 and goes to 0. Then I noticed that the maximum of my range is going to be what? Plus 1. Do you see that? Okay, now, if you have, I wish if I had used, I should say my the other paper, which is graded. And if, for example, for 0, I'm going to plot it. For 0, how much is the y, guys?
0.
0. For 0, it's going to be this. For pi over 6, and let me also divide this one with 2, becomes pi over 2. Seven 30. That's right. And this one also becomes pi over 2. For when you are pi over 6, how much you are going to get for y? Pi over 6, you get 1 over 2, huh? You should 1 over 2. For when you're pi over 4, you should that square root of 2 over 2. Let me see. It's going to be here. When you're pi over 3, it's going to be here. And also the same thing. You can find any number which you have for the x and show what the value is going to be the x. When you do that, now we just want to do what? We want to connect these dots together. Let me see if that's going to be the same angle. This is going to be -1 here. This is going to be this. Let's see. Okay. Now it's a very reasonable plot. Guys, are you still there?
Yes.
Okay. Okay, now this is the first plot that we were able to just make, I should say, of the sine function. And you will see that the plot of the sine function into one full of a circle, which is between 0 to 2 pi, takes this form. Huh? This is the first cycle of, I should say, the plotting of the function. Of the plot of the function is going to be the sine of the x. We are going to talk about that more, I should say, in future. But before we leave, I'm going to show that to you guys. This type of function, you see that. What is the range? What is the domain of this function, guys? And this plot which I have made. This is between 0 to 2 pi. That's right. That's going to be the domain of my function. It's true. What is the range of this function? It is between -1 to +1. You see that?
Yes.
Yes. Why this is between -1 to +1? Because come back to this plot, to this graph which we have. Look at here. The y-axis always shows the value of your sine. And you see that it varies between 0 goes to +1, then comes back again, goes to -1. You see that oscillates between these two maximum value. You see this?
Yes.
That's right. Then always, guys, remember, the range of any sine function, as you can see from, I should say, the unit circle, the map which we produced, it takes to the maximum +1 and it goes to the minimum -1. Then for any sine function, which any forms it takes, it's always between -1 to +1. Okay? And now, you see that the plot which I have created, it's between the 0 and 2 pi. And this becomes, I should say, the most fundamental, I should say, building blocks of plotting any sine function. It means that after 2 pi, it's going to be repeated ones. I'm going to give you a quick example to that. Guys, have you seen that when you just want to make a house? You know what is a brick, huh? For example, you want to build a house. For example, you say you put the bricks together, that's right, one by one, and becomes to a house, huh? Guys, are you there?
Yes.
And this is exactly the same thing for the functions like the sine and trigonometric function. The figure which you get for one full circle, which is between 0 to 2 pi, it's essentially like the brick which you're going to make the house. When you want to make a house, if you have a brick, for example, you put one brick here, you put the next brick next to that, you put the next brick next to that, you put the next brick next to the other one, and it makes the house, correct? For the trigonometric functions, it becomes like this. For example, when you have the full plot, if from between 0 to 2 pi, the plot looks like that, to 4 pi, you take another one, you connect to that. You see that? I'm going to show that to you something on the Desmos. I'm going to share my screen to show something to you on the Desmos. Guys, if you are still there, say your name.
Rose.
Gloria.
Philip.
Philip? Ah, okay. How about Ferris? Oh, Ferris is gone. Okay, now, look at this. I'm going to plot the function sine of x. Look at that. You see my screen? Yes, guys, you see my Desmos?
Yes.
Yeah, look at that. This is the sine function. I plotted it. Look. Isn't that crazy? It goes everywhere. You see? The same thing over and over again. Let me minimize it. You see that, guys? It means that for one circle, which is going to be this from 0 to here, it gets repeated at every interval. We're going to talk about this quality, which they call that periodic function next session. But you see that this function, if you know how the function looks like in one single cycle, which is from 0 to 2 pi, it gets repeated all over the x-axis, right? For example, you see that even goes to the minus, it goes all the way. You see there is no change to that. You see? It's a continuous pattern. You see this, guys? Even if I minimize it like that, you see it goes all over the place. You see? You see, it's like the brick and it gets repeated over and over again. Any questions, guys?
No.
No? How about you, Philip and Gloria?
No.
Philip?
No.
No. Okay, guys, there is one thing I just wanted to mention, that for tomorrow, I have an exam myself. We have no class tomorrow. I'm just going to post homework today for you, and you have to finish the homework by tomorrow night then. Then you email your homework to me. Okay?
Okay.
Awesome. And when we come back on Thursday, we have a midterm. Okay?
Okay.
Awesome. Any questions, guys?
No.
No? Then I see you all, I should say, on the day after tomorrow then. Have a nice day, guys. Goodbye.
Bye.
Bye.
Bye, everyone.